Hey guys, welcome back to my CCNA 200-301 course. Patrice is here, and in this video I'm going to show you how you can configure layer 2 port channels. Are you ready? Let's get started. This is our today's scenario. As you can see, it's been implemented in EVE-NG. We have two switches, switch 1 and switch 2, and we have a redundant link between these two switches. Let's see how we can configure layer 2 port channel between these two switches. Before I jump on the layer 2 port channel configuration, I want to show you what would happen if you have redundant path between your switches and you don't configure port channels. In these circumstances, another protocol called Spanning Tree Protocol, or STP, which I'll be talking about it in the upcoming videos, will kick in and will prevent those redundant paths to create loops in your layer 2 infrastructure. So if I go to switch 2 and run show spanning tree, you'll see that one interface is in forwarding status and the other one is in blocking status. Don't worry about these terms, we'll be talking about them in the upcoming videos. But for now, just know that because of this setup, at the moment, one of those redundant links actually doesn't work because spanning tree blocks it. So only one of those two links is working, so you cannot benefit from that extra link you ran between the two switches. If you remember from the previous video, I mentioned we have two types of port channeling. The first one is static and the second one is dynamic, where you use dynamic protocols like PACP and LACP or LACP. First, I want to configure the manual one, which is just setting up the port channel. So first I go to switch 1 and I'm going to global configuration mode and pick my interfaces, interface range Ethernet 0/0 to 1 on this switch. One of the recommendations to configure port channels is when you select your ports, first shut them down and then configure the port channel on them, and once all configurations are in place on both ends, then bring the interfaces up. So as the first step, I shut down these two interfaces. And to configure port channel, the command we're using is channel group, and in front of channel group you have to pick a number for your channel group. This number is locally significant, so it doesn't have to be the same on the switches of the switches that we're going to configure port channel between them. So on one switch it can be channel group 1, on the other one can be channel group 2. So it's up to you. But obviously it's better to be the same on both ends. But if for whatever reason you use another number for another port channel on one of the switches, it's fine. It's just a local significant number. And then we say mode on. So as you can see, the switch sends you a message creating a port channel interface, port channel 1, which shows you port channel 1 is being created on the switch. Now we have to go to the other switch and replicate the procedure on the other one too. On the second switch also, we pick our interfaces, Ethernet interface range Ethernet 0/0 to 1. First shut them down and then channel group 1 mode on. There is another recommendation with port channel setup. If you want to configure port channel, first put the interfaces in port channel and then start to configure other parameters. Like for example, if this is a layer 2 port channel, like what we configure it now, is like if you want to make that interface trunk. or put it in a specific VLAN whatsoever. Once the port channel is created, then you go to the interface port channel and then you configure it. Okay, so now we configured port channel on both sides. Why we call this a layer 2 port channel? A layer 2 port channel means this link is in layer 2. It's just like you configure two switches and connect them together, and the interfaces on each end, they are in the same layer 2 configuration, like they are in the same VLAN, they are in trunk mode. So it's a layer 2 communication. So we call this a layer 2 port channel. This means both ends are in layer 2, whatever. If they are in an access VLAN, voice VLAN, or a trunk, both ends are in layer 2. Once the interfaces are up, once the interfaces are configured, then we bring them out of shutdown. This is switch 2, and then I go to switch 1 and bring the interfaces out of shutdown mode here as well. As you can see, the messages now are interface 00 is up, interface 01 is up, and also interface port channel is up. So interface port channel is an identity on your switch now. It's a different type of interface that is being added to your switch. So now on this switch, if I clear my screen and run show interface status, you can see that beside the ports that was already on the switch, we have another interface as well, and that is port channel 1 or PO1. The verification command for port channels is show ether channel summary. I know it might be a bit confusing when you deal with these things for the first time. Okay, the technology is called port channel. When we configure them, we say channel group, and then once we want to verify it, we say show ether channel. Different terminologies for the same thing, but it is what it is. So here, as you can see, we receive some information. Channel group 1. This port channel interface is port channel 1 and it is SU. S means, where is S? S is not this one. This is the small s, which is not a good thing because that means that interface is in suspend mode. But this is the thing. S means it is in switch mode or it is in layer 2 mode. With this letter, you can figure out if this port channel is in layer 2 or in layer 3, which we'll be talking about it in the next video. And here that is the thing. Protocol, nothing. We don't have a protocol because we just configured this interface, this port channel, in manual mode. So we didn't pick any specific type of channel group protocols. And this is another thing that you need to be careful. This is so important. You need to make sure that all interfaces that are supposed to be in the port channel are actually active. P means bundled in the port channel. So this is important. All of these interfaces should have P in front of them so we can make sure that they are actually participating in the port channel and they are working. Other letters like S or sometimes D means that, or I, even I means a standalone, are not good signs. That means that that interface has a problem, either suspended or physically down or administratively down, whatever, or it is in a standalone mode. In a standalone mode means that it's not participating in the port channel. If you have many port channels, and show ether channel summary is very a busy output for you, you can customize this command for a specific port channel by using show ether channel 1, or your port channel number, and then summary. Here I just have 1, so there's no any difference between show ether channel summary and show ether channel 1 summary. But if you have many port channels, then this command will help you to customize your output for a specific port channel number. Now, if I flash back to spanning tree and run show spanning tree once again, you can see that Ethernet 0/0 and 0/1 is removed from the list, and instead port channel 1 is here and it is in forwarding status. So in spanning tree perspective, there is no Ethernet 00 or 01. Both of them are bundled and logically has become port channel 1. And that port channel is in a forwarding state, which means that it's working. Now I want to show you how you can use dynamic port channeling protocols. First, I have to remove the interfaces I had from the current port channel. So I select the interfaces 0, 0 and 1, and then no channel group, and then shut down for now. Then I go to switch 2 and run the same commands, no channel group and shut down. Now if you go back to switch 1 in the same interfaces, Ethernet 0, 0 and 1, and the command is the same, channel group, and then you give it a number and then mode, but here we have the other options. We can, if you want to use LACP, you say active or passive. And as I mentioned in the previous video, both sides cannot be passive. One side should be active, the other side can be active or can be passive. So someone must start the conversation. The side that needs to start the conversation has to be in active mode. Similar thing for PAGP. If you want to configure PAGP as a negotiation starter, you have to say desirable. And if you want to be the listener for PAGP, it is auto. And obviously, when you're configuring a port channel, both ends should be able to speak with the same language. So if you pick LACP or LACP, it has both ends has to be LACP. So you cannot mix and match PAGP and LACP. So for now, I select active for switch 1. Similar thing for switch 2. I want to change 2 things here. First, the channel group number, so you can see that it's completely independent between the 2 switches. And then change the mode of this one to passive. And then no shutdown. Similar thing on switch 1. Now, if we're on show ether channel summary, you can see that everything is the same. It's a layer 2 port channel. Port channel number is 1 on switch 1. And things have been changed here. And instead of just a dash, it turned to LACP, which means that at the moment, for channel group negotiation, we're using LACP. And if I go to switch 2 and run same command, you can see that this one is having LACP as well, but the channel group number is 2. Since I didn't delete interface port channel 1, it is still here. So I had to say no interface port channel 1 as well, so this one can be removed. But here, what I wanted to show you is this number is locally significant, and it doesn't have to be same thing on both ends. And here we have the LACP as well. The final thing I want to talk about it is load balancing. As I mentioned before, one of the benefits of port channeling is actually combining the capacity of the links, so you can benefit from extra bandwidth. But the question is, okay, if we have multiple links and we are expecting to have load balancing on those links, what would happen, or how switches actually doing the load balancing over multiple links? The thing is, load balancing is actually something internally. So this is the switch that decides how different flows has to load balance over the links based on an internal mathematics. But the thing is, we can tell the switches at least based on what parameter do the load balancing for us. And the thing is, switch uses the lower bits of the packets to decide about where it should send it, or I mean over which link it should send the traffic to. But the thing is, we can tell the switch based on what parameter you should decide about the load balancing. Basically, we can do load balancing based on layer 2, layer 3 and layer 4 information. Obviously, layer 2 means MAC address. So we can tell the switch to actually do the load balancing based on source MAC address, or based on the destination MAC address, or based on the combination of source and destination MAC address. Similar information or similar thing for IP, source IP address, source, if I say MAC here, source MAC or destination MAC, or source IP address or destination IP address, or source and destination IP address, which then switch does an XOR operation on the packets and then actually decide which link it should send it. And or port, source port, destination port, or source and destination port, which means TCP and UDP ports. The thing is, first, this setup is happening globally. So you cannot change it per port channel. So you can decide about which one best suits your network and then apply it on the switch globally. The other thing is, all of these load balancing algorithms might not be available on the platform you are trying to configure this. These are the available ones generally, but depends on the platform you're using or you're managing, and also the iOS version you're running on that platform. Some of these options may not be available on that switch. To configure your port channeling load balancing algorithm, as I mentioned, it's a global setup. So we have to go to global configuration mode, and the command is port channel and then load balance and then the options. On this switch, as you can see, we don't have all options. These are the available options on this switch. Destination IP address, destination MAC address, destination and source IP, source and destination MAC address, and then source IP or source MAC. These are the available options for us. To figure out what is the current load balance algorithm on your switch is show ether channel load balance. This command will show you what is your current load balance algorithm. So on this switch is source destination IP. So you can run it on your switch and figure out what is your switch load balancing algorithm. There is an interesting command on Cisco switches which unfortunately doesn't support on the platform I'm using, is test command. Test command can help you to figure out, or you can ask switch, if I want to send traffic, for example, between this MAC address and that MAC address, or only from this MAC address, which interface will you pick on this port channel? That command is test, I'm just writing it for you, ether channel, and then you have to mention your interface, which interface port channel, for example, interface P01, for example, and then give it the MAC address. MAC address like A, with the MAC address format of the Cisco switches, obviously, and BBBB, BBBB, and BBBB. With this command, if your switch supports it, you can ask switch, okay, if I want to send traffic between this MAC address and this MAC address, which interface will you pick within this interface port channel? And the switch will tell you, would select like Ethernet 0/0 or 0/1, for example. Or you can try it with the IP addresses or port numbers as well, if your switch supports this command. Alright guys, this was our today's video. In the next video, I'll be talking about layer 3 port channels. I wish you enjoyed today's video and see you in the next ones.